Bismillahirrahmanirrahim. Assalamu alaikum students. We are studying the chapter of thermodynamics. The topic under today's discussion is the continuation of yesterday's topic, which was the entropy change in terms of temperature and volume. Today we will study the entropy change in terms of temperature and pressure. Note: please keep in mind that in the start you will write all the description which is given for entropy change in terms of temperature and volume. So you will write above this all this description here. Then we will continue that our topic, and we will take the equation which was del S is equal to CV log natural T2 by T1 plus R log natural V2 by V1. Consider it as equation number 1. For 1 mole of ideal gas, the general gas equation is P1V1 is equal to RT1. N is equal to 1 mole. P2V2 is equal to RT2. This is the equation number 3. Divide equation number 3 by equation number 2. P2V2 by P1V1 is equal to T2 by T1. You will cancel these R with one another, so it will left only T2 by T1. V2 by V1 is equal to, we can write here in this form, V2 by V1 is equal to P1 T2 divided by, bring this P2 here, P2 T1. This will become equation number 4. Put the value of equation number 4 in equation number 1. Del S is equal to CV log natural T2 by T1 plus R log natural. Write the value of V2 by V1 here at this point. R log natural P1 T2 divided by P2 T1. This will become equation number 5. As we know, Cp minus Cv is equal to R. As I have told you yesterday, then that Cv can become equal to Cv is equal to Cp minus R by multiplying this equation by minus. Cv is equal to Cp minus R. Put the value of Cv in equation 5 here at this point. Del S is equal to Cp minus R log natural T2 by T1 plus R log natural P1 T2 divided by P2 T1. Here at this point, we will use the log rule. According to that, the values which are subtracting, we can write them in the form of this, in this form, as del S is equal to Cp into log natural T2 by T1 minus R log natural T2 by T1 plus R log natural P1 by P2 plus R log natural T2 by T1. Cancel this R log natural T2 by T1 with this R log natural T2 by T1. So the value left will be del S is equal to Cp log natural T2 by T1 plus R log natural P1 by P2. This equation tells us the change of entropy for 1 mole of an ideal gas when the temperature changes from T1 to T2 and pressure changes from P1 to P2. The conclusion of this equation will be, if T2 is greater than T1 and P1 is greater than P2, then del S is positive. It means entropy is increasing. Similarly, if T1 is greater than T2 and P2 is greater than P1, then del S is negative. It means entropy is decreasing. Our next topic is the discussion of few definitions which are concerned with our next topic. First is the heat engine. The machine which is used for the conversion of heat into work is called heat engine. Source: the heat reservoir from which engine absorbs heat, and it is at higher temperature. It is known as the source. Next is the sink. It is opposite to the source, the heat reservoir which absorbs heat from engine, and it is at lower temperature. At this point, heat reservoir is taking the heat, engine is taking the heat, and at this point reservoir is taking the heat from the engine. Cyclic process: if a system returns to the original stage after completing a series of changes, is called cycle. Next is the definition of thermodynamic reversible process: the reaction that takes place infinitesimally slow. It means very slow. Infinitesimally means very slow, and its direction at any point can be reversed by an infinitesimal change in some conditions such as temperature, pressure, or concentration. It means it is considered to proceed from initial state to final state through an infinite series of infinitesimal stages. It means if we want to go from one end to another end, like this is the temperature T1 and we will go at this point at temperature T2, it will take very small stages in this like this, and we can reverse the reaction at any stage. You can say that we can reverse this reaction at this stage, but this reversal can be achieved by changing the condition, either pressure, temperature, or volume. Next is the irreversible process. When a process grows from initial to final state in a single step and cannot be carried in reversed order, it means we can't change its direction, said to be irreversible process. All naturally occurring processes take place in finite time, means Mehdud time, and are irreversible. Just like life itself goes in one direction, it means life is going through a irreversible process. Similarly, digestion of food, it is also a irreversible process. So it is known as the real process. Next is the spontaneous process. A process which is real, irreversible, occurs without any outside assistance. Assistance means help, and moves from a non-equilibrium state towards an equilibrium state is called spontaneous or natural process. For example, flow of water from higher level to lower level. It is a natural phenomena that water always flow from higher level to lower level. As it is a natural phenomena, so it is known as the spontaneous process. Heat transfers from hotter body to colder body. It is also a natural process. Next is the non-spontaneous process. It does not proceed on its own accord, means अपनी मर्जी से, and it is unnatural. It can made to occur only by supplying energy to the system from external source. For example, pumping of water up means when we want to pump the water from lower story to upper story, we will take the help of some electrical pump. The pump will act as an external source. Similarly, flow of heat from cold end of a metal rod to a hot end. Next is the isothermal process. We have studied the adiabatic process before. Now we are studying the isothermal process. The process in which temperature of system remains constant during each step. It means dT is equal to 0. dT is equal to 0 means change in temperature will not take place. This is often achieved by placing the system in a thermostat. Thermostat means the body which keep the temperature constant. Second law of thermodynamics. This law can be stated in a number of ways. First definition of second law of thermodynamics is the Clausius statement. It is impossible to transfer heat from a cold body to hot body without the expenditure of energy. Next, Kelvin statement. It is impossible to construct a heat engine operating in cycles. I have told you the definition of heat engine and the definition of cycle. Now we are using this term. So I am repeating this definition. It is impossible to construct a heat engine, means any device operating in cycles which can convert heat into equivalent amount of work without producing other change in the system or its surrounding. It means when any heat engine works, it will convert the heat into work. But heat engine or the body which is working, it will either heat up or will produce some sound. So when it will heat up, it will bring the change in the surrounding. The surrounding will be hot. So we say that which can convert heat into equivalent amount of work without producing other change in the system. It will produce the change in the system. Third definition is all the spontaneous processes are thermodynamically irreversible. Spontaneous processes are generally natural processes. So natural processes are generally irreversible. Next is, it is impossible to convert heat into work completely without leaving some effect. It is like the second definition. It means when we convert heat into work or work is done by the system, then the body from which work is going on, it will either heat up or it will produce some sound or it will show some change in its formation. Next is the Rudolph Clausius statement. The energy of the universe is constant. It means when any system is working, it will transfer heat to the surrounding. So overall, the universe is made by the combination of both the system and surrounding. So the energy of the universe is constant, but the entropy of the universe is constantly increasing. Entropy means disorderness. Disorderness of the universe is increasing. Next is when a process is carried out reversibly, the entropy change in the process is zero. Reversible means when it will move in the forward direction. At the same time, when it will move at the reverse reaction, it will complete a cycle. So the end result of the process will be zero. Thank you.